All right, so Venus, and I think I was right about here in the last one. Venus may have had oceans in the very early stages of its evolution, and but what would have happened is, um, as the greenhouse effect got greater and greater, all of the, and any, remember, water vapor is a much greater um, greenhouse gas than even carbon dioxide. It traps heat more efficiently, so that if there were any oceans or any bodies of water on the surface of Venus, they would have boiled off long ago and just kept the surface extremely dry. Um, all right, so this is so this is the thing. I think I mentioned this before, but um, that there's some features on Venus, that when the spacecraft Magellan, although it's not talking about Magellan yet, Magellan was the spacecraft that orbited Venus for quite a while, and gave us um, a lot of information about it, about the size of the mountains and everything. Um, what NASA scientists decided to do, is to name a lot of the features on Venus after female, either mythical figures, like, here's, like, for example, Aphrodite, right? Aphrodite Terra. That's this feature right here, is Aphrodite was a goddess, but there are some places, um, you know, there's some other ones that are, like Ishtar. I think I'm not sure what. I don't think. I think that's also a goddess. But yeah, there's some features on here that, here. Let me see if I can find anything. Um, no. Uh, yeah. Well, yeah, they're just these are just the larger features of on Venus. But anyhow, so they try to name them after both female mythical figures, gods and goddesses, I should say, and then also some living, or some actual human beings as well. Uh, all right, let's see. So this is the difference in the heights. If this is what we would call ground level, that you find places on Venus up to, 8 kilometers below that, and then about 8 kilometers above that. Although, there's most of it is actually a little bit below, right? See they indicated with the blues, right? The blues are not water; they're just showing you. See, Venus's surface has less mountainous and than Earth. Um, it's basically like, these gentle hills. I mean, they're mountainous, but they're not extremely steep. Um, all right. Let's see. Two major highlands are Ishtar Terra, so that's this one up here in the north, and then Aphrodite Terra. The Terra just means the land, um, and they're both about 8% of the surface, and they rise above the plains. All right. So anyhow, those are just. Remember, this is all the surface of Venus. Some of it is a little higher, and some of it is lower. These are some of the different volcanoes. Let's see. This is actually an impact crater right here. We do see evidence of volcanic activity, but not current activity. So there's some lava domes that we saw on the surface of Venus. Remember, this is all with radar, right? This is not actual. These are not actual visible pictures, but they're pretty good. You can make out some really fine details with these. Very few plates with tectonic features. Um, yeah, we don't really see the plate boundaries. Let's see what else. You know how we do on Earth, which is kind of surprising to us because we thought Venus would be a lot more like Earth, and yet it's its own world. It's quite different. Um, so there are some impact craters, but there's not a lot. I mean, that's another thing. Is the surface of Venus is undergoing change. That's probably the biggest lesson on out of all of this, right? It's not nearly as cratered as our moon or Mercury, where when craters hit those two worlds, the evidence is there, for billions upon billions of years. We think that, of course, craters do hit Venus. Sorry, there are things that impact Venus, comets and asteroids and things like that. But that evidence gets erased due to weathering, right? There's weathering going on Venus. And we think there might even be some geological activity, although we didn't see any direct evidence of that happening right away. I mean, there's these lava domes, things like that. There's areas that look like it's where lava flowed, but that was not going on when we were observing. This is actually called a shield volcano. Shield volcanoes it's a very simple idea. If you think, back when humans used to have, swords and shields and fought each other that way. If you took a shield and you laid it on the ground and, where the bump part is up, that kind of that's where a shield volcano gets its name. That's all that is. This particular one, Indun Mons, which is just that's the name of it. It looks like it had recent lava flow. Recent means within the last few tens of millions of years, or even hundreds of millions of years. That's relatively recent. I actually think it's more recent than that even. Let's see, young surface. These features indicate a young and active surface. So let's see, Venus's original surface would have been destroyed by volcanic activity, and the current surface is not more than 500 million years old. Much younger than Earth's, right? There's some regions less than 10 million years old, we think, on Venus. All right. Venus is not Earth's twin, not at all. Even though it's virtually the same size and virtually the same mass, the interior of Venus is probably very similar to Earth: an iron, rocky core and a rocky mantle. Venus still evolved into the smooth heat flow patterns that we find on Earth. Earth rocks have more. Our rocks can trap water more, and whereas the Venuses do not. We don't see as much of the. So see what it says. They're just saying the water, though there's a lot of water on Earth rocks, which is absolutely true. In fact, that was actually a big surprise when we brought home moon rocks from the Apollo astronauts. They were incredibly dry. There was hardly any water. Even rocks that you pick up on the ground, they still have water in them. And we were really surprised that the moon rocks did not. And it turns out that Venus's rocks don't appear to have a lot of water. The one mission. I think they had maybe two missions that actually was successful and took some pictures. It actually looks very similar to the surface of Mars, right? Rocky material. So this was the Russians, one of their Venera programs. Like I said, these things did not last for very long. And many of them never even made it onto Venus, but they did successfully land one, and it might have been two, could have possibly been three of them that landed. I'd have to look that up, but and they did take pictures, and as long as these things lasted, as long as the electronics lasted, which was not very long. I think the longest one was like an hour and a half, maybe 2 hours, something like that. The interior of Venus. The interior of Venus is probably similar to the Earth. Water content in the interior rocks is much lower than on Earth, the result of more viscous lava. Yeah, all right. So this is notice the remember for the Earth is 6,400 kilometers. This one's a little less than that. There are, of course, is the nickel iron core. There's a silicate mantle, just like the Earth. The rotation. All right. So now here's the thing. So because you can't see the surface of Venus, it's hard to tell how long it takes it to rotate, right? So radar measurements show that Venus rotates. It's the slowest rotating planet of them all. It takes 243 days, Earth days, to rotate around on its axis just once. And the other thing that's really odd, and it's the only planet that does this, is remember, like you got to think about the solar system. Everything in the solar system is rotating around the sun in a counterclockwise direction. And most of the things in the solar system are spinning around on their own axis in a counterclockwise direction. Whereas Venus is not. It's going around the Earth, the sun in a counterclockwise direction, just like all the planets, but it's actually spinning around on its axis clockwise, right? So it's actually going clockwise around its axis. So in other words, this is what people have thought about, is that at some point in the past there was a huge impact with Venus, and it probably like hit near one of the poles, and it basically flipped Venus around. It flipped it upside down, and that's why we see this clockwise rotation, which, by the way, is also known as retrograde rotation. Remember how we talked about before retrograde motion, when it looks like a planet. Now the retrograde motion was just an optical illusion. This is not an optical illusion. Venus really is spinning clockwise. Now it goes very, very slowly. It spins really slowly, as it says right here, it's too slow to generate a magnetic field. Remember, the motion has to be fast enough to generate a magnetic field. Slow rotation and retrograde, right? So there's just giving you, what it looks like. Venus has spun almost all the way around when one day has occurred. Okay. All right. So that is Venus. Let's see. We're just about done. We're done with that. Let's turn to. Well, I'm gonna start Mars independently in just a moment on a different video. But there's the wonderful planet Mars. You can see its surface because it has a relatively thin atmosphere. There's one of the main features is the polar ice caps